Welcome to part 2 of this series. In this video, we learn the basics of factorization formula and solve 6 examples. Hello, math champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, this is the second session of factorization. What we focus on this session is how to use some factorizing formulas and how to use the cross-product method to perform factorization. First, let me start to present you a number of common useful formulas. The first formula is a popular one. Usually we call it the difference of two squares. The main issue here is to identify simples a and b when applying it. Simples a and b can be a single variable, a combination of a few variables, or a complicated algebra expressions, or even a simple number. This formula can be easily proved by expanding from the right-hand side of the equation. The second formula is the completing square. When taking the upper sign on the left side of the equation, the right-hand side of the equation also takes the upper sign, and this also applies to the lower sign. Conventionally, we use such a way to combine two formulas into one, and it will be seen in the formula shown later. Again, this formula can be proved by expanding from the right-hand side of the equation. The next formula is the quadratic trinomial. The so-called cross-product method can be demonstrated here. Basically, factors of the quadratic and the constant terms are regrouped to match the linear term. In this case, we see x squared can be separated by x times x, while the constant a times b can be separated by a, b. They time each other, which can be seen in the diagram. After performing the cross product and then add them up, we find the result matches the linear term of the quadratic trinomial. The next formula is a completing square for 3 variables. The proof can be done by expanding from the right-hand side of the equation. Of course, the proof can also be done by regrouping and taking the common factor from the left-hand side of the equation. The next formula is a factorizing formula for the difference of 2 cubic variables. As mentioned earlier, when one side of the equation taking the upper sign or lower sign, the other side of the equation should be done in the same way.
Now we are going to explain how to apply these formulas as well as the cross-product method by going through some examples. Let's take a close look at this example. It contains negative sign, numbers in fraction form, and variable x. As said in the last session, the first step is always to look at the common factors of all the terms. And here we take out the negative sign 1 over 27 x to the 2n. After doing so, the remaining parts of the 3 terms are put in the square bracket, and that just match a complete square pattern. Recall the complete square formula and make a comparison with what we have in the square bracket. Then we proceed with the completing square method to finish the factorization. Example 2 is to factorize 7x squared minus 125y squared. Intuitively, we will try the formula of the difference of 2 squares here. Now, the first thing to do is always to look for common factors of all the terms, and we find number 7 is the common factor in this case. After taking out the common factor 7, the remaining of the expression is x squared minus 25, which is 5 squared. So we apply the formula of the difference of two squares to finish the factorization. Example 3 is to factorize an expression of x cubed minus 2x squared y plus xy squared minus x. As mentioned before, the first thing to do is to check if there's any common factor in this expression. However, we find x is the common factor of all the terms, and we take it outside the parentheses, while the remaining parts of these terms are placed inside the parentheses. After further inspecting on the remaining parts of these terms, we find the three terms of x squared, negative 2xy, and y squared just form a complete square. Recall the complete square formula again, and then identify which one belongs to the polynomial A, which one belongs to the polynomial B. Then we proceed to make these three terms a complete square, and then applied the formula of the difference of two squares to finish the factorization. Example 4 is to show how to use the cross product method to factorize a trinomial quadratics of 63x squared plus 22x minus 8. Recall the cross product method as shown here again. We apply this method onto this example. First, we need to find all the prime factors of the quadratic term 63x squared, as well as the prime factors of the constant 8. In this way, 63x squared can be factorized to 3 squared times 7 times x squared, while 8 can be factorized to 2 cubed. Then we try different combinations of these factors and see if they can match the linear term of 22. Fortunately, we find a combination which satisfies the requirement as shown on the screen. So the expression can be factorized as 9x minus 2, or in parentheses multiplies 7x plus 4, or in parentheses. Example 5 is to factorize the expression of x cubed multiplies x minus 2y, or in parentheses, plus y cubed multiplies 2x minus y, or in parentheses. Let's observe the expression and imagine various possible approaches to use the factorization formula as our thinking base to find a way to manage it through. You may pause this video and try it out yourself. However, we just do it straight away here. First, we expand these two parentheses of the expression and rearrange the four terms. Then we place x to the 4 minus y to the 4 as the first group, while let the other two terms to form another group. In the first group, x to the 4 minus y to the 4 can be factorized using the formula of the difference of two squares, while in the second group, 2xy is the common factor that can be taken out. Now, the remaining terms in both groups are the same, and they can be regarded as a common factor of both groups. After taking out the common factor of x squared minus y squared, the remaining three terms in a square bracket just form a complete square. So we proceed to finish the factorization as shown here. Example 6 is an application of using the factorizing skills we just learned to find two factors of this large number, 2 to the 48 minus 1. You may take some time to read and understand this question first. Now, in order to find two numbers that satisfy the requirement, we need to factorize this large number. Now 2 to the 48 can be expressed as 2 to the 24, or in parentheses squared, as shown on the screen. Then we recall the difference of two squares and continue to factorize it. Again, 2 to the 24 can be expressed as 2 to the 12, or in parentheses squared. We go down this path to repeatedly apply the formula of the difference of two squares and factorize this large number to the form shown in red color on the screen. The last two factors are 2 to the 6 plus 1 and 2 to the 6 minus 1, which are 65 and 63 respectively. So we find that the number 2 to the 48 minus 1 can be divided exactly by 63 and 65.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.